Assalamu alaikum wa rahmatullah. Today we have a new lesson of geometry. Our lesson is cyclic quadrilateral. What is cyclic quadrilateral? What is the definition of cyclic quadrilateral? Cyclic quadrilateral means quadrilateral figure whose four vertices belong to one circle. As we can see here in the opposite figure, A, B, C, D is cyclic quadrilateral because its vertices A, B, C, and D belong to the circle M. Properties of cyclic quad. The first property, in cyclic quad there are two angles subtended by the same base and on the same side of it have the same measure. Look at the opposite figure. The property is there is two angles, drawn on the same base of the quadrilateral and on the same side, on the same direction from AB. The two angles here are equal in measure. That means measure angle C equals measure angle D. Again, in the opposite figure, angle C and angle D are drawn on one side, AB, and on the same side of it, on the same direction of this base. So, measure angle C equals measure angle D. Property number 2. In cyclic quad, each two opposite angles are supplementary. Again, each two opposite angles supplementary. That means measure angle A plus measure angle C equals 180, and also measure angle B plus measure angle D equals 180. Property number 3. In cyclic quad, the measure of exterior angle of the cyclic quad at vertex of one vertex of cyclic quad is equal to measure of interior angle at opposite vertex. Again, here ABCD is cyclic quad and angle CBF is exterior angle of this cyclic quad. So measure angle CBF equals measure angle D. Measure angle D, interior angle of the cyclic quad, opposite to the vertex of exterior angle. So the measure of exterior angle equals the measure of angle D. Now the last property, property number 4. In cyclic quad, there is a point in plane of the figure in cyclic quad is equidistant from the four vertices of the cyclic quad. Look at the figure. Here I have cyclic quad ABCD and I have point in the plane of the cyclic quad. This point is equidistant from the four vertices ABC and D. That means QA equals QB equals QC equals QD. Now drill number 1. In each of the following figures, find the measure of each angle. Number A. He asked me to find the measure of angle ABD. Where is angle ABD? Look at the figure. ABD. I want to find the measure of this angle. What is the given here? Firstly, ABCD is cyclic quad. Why? Because the four vertices belong to the circle. And measure angle ADB equal 30, measure angle CDE equals 70. Now, if I have cyclic quad, so I have 4 properties. Okay? Now, which property in this figure? Look at angle C, measure angle C equals 70. What about measure angle A? What is the relation between angle A and angle C? Yes, two opposite angles in cyclic quad. Therefore, A and C are supplementary. That means measure angle A equals 110. Now, in triangle ABD, measure angle A 110 and measure angle D 30 degrees. Therefore, measure angle B equals, yes, equals 40 degrees. Now, number B. Cyclic quad also ABCD, and I have measure angle DMB equals to X, measure angle BCD equal to X also. And he asked me to find the measure of angle A. I want to find the measure of angle A, this angle. What is the relation between angle A and angle DMB or angle C? Now, firstly, measure angle A is inscribed angle subtended by arc BD, and also measure angle DMB central angle subtended by the same arc BD. That means measure angle A is half measure angle DMB. So measure angle A here half to X. So measure angle A equals X. Now measure angle A equals X. And measure angle C equals 2x. What's the relation between measure angle A and measure angle C? Yes, measure angle A and measure angle C are supplementary. The two angles are supplementary. Why? Because ABCD is cyclic quad. That means the value of x or 3x equals 180. Then the value of x equals 60. So measure angle A equals 60 degrees. Drill number 2. In the opposite figure, measure angle ABE equals 100 degrees, measure angle CAD equals 40 degrees, and he asked me to prove that measure arc CD equals measure arc AD. Measure arc CD, this arc, okay, equals measure arc AD. Now, from the given, here I have cyclic quad ABCD, and I have exterior angle of the cyclic quad. Angle ABE is exterior angle of cyclic quad ABCD. Therefore, measure angle B, the exterior angle B, equals the interior angle which opposite to the vertex of this exterior angle. So, measure angle D here equals 100. This is first point. Now, how to prove that CD, measure arc CD equals measure arc AD. This arc equal measure this arc. When the measure of two arcs are equals, if I have two inscribed angle of the two arcs equal in measure. Let's see. Here I have arc CD subtend the inscribed angle A. So measure arc CD equals 40 degrees. What about the angle, inscribed angle C, which is subtended by the arc AD? If measure angle C equals 40 also, let's see. In triangle ADC, measure angle A 40, measure angle D equals 100. Therefore, measure angle C equals 180 minus 140. So measure angle C equals 40. That means the measure arc CD equals 40 and also measure arc AD equals 40. Let's see our steps. In cyclic quad ABCD, since measure angle ABE is an exterior angle of cyclic quad ABCD. Therefore, measure angle ABE equals measure angle ADC equals 100. In triangle ABC, measure angle ACD equals 180 minus 140 equals 40 degrees. Now, since measure angle ACD equals measure angle CAD equals 40, so measure arc AD equals measure arc CD. Now, let's summarize what we said before. I said before, if I have cyclic quad, if the given is cyclic quad, then I have the four properties of this cyclic quad. But if I wanted to prove that the quadrilateral is cyclic quadrilateral, what shall I do in this case? So I'm looking for about one property, just one property from the four properties. So the quadrilateral is cyclic quad if one of the following conditions is verified. So I'm looking for about one condition to prove that any quadrilateral is cyclic quad. Number one, if there are two equal angles in measure and drawn on one of its sides as a base on one side of it. Okay, this is number one. Number two, if there are two opposite angles are supplementary. Number three, if there is an exterior angle at any of its vertices equal in measure to the measure of an interior angle at the opposite vertex. The last problem is the last condition. If there is a point in the plane of the figure such that it's equidistant from its vertices. Now, if I want to prove that any figure, any quadrilateral is cyclic quad, so I'm looking for about one condition only. Now, exercise. In each of the following figures, prove that ABCD is a cyclic quad. Here I have three figures, 1, 2, and 3. And I want to prove that each of them is cyclic quad. So, I said before, if I want to prove that any quadrilateral is cyclic quad, so I will looking for about one property from the four properties. Look at number A. Number 1. ABCD is quadrilateral, measure angle A 97 and measure angle C equals 83. And I want to prove that this figure is cyclic quad. Now, of course, ABCD is cyclic quad. Why? Because I have two opposite angles, A and C, are supplementary because their sum of their measure equals 180. Let's see our steps. In quadrilateral ABCD, since measure angle A plus measure angle C equals 180, because 97 plus 83 equals 180, therefore angle A and angle C are supplementary angles. That means quadrilateral ABCD is cyclic quad. Now look at figure number 2 and figure number 3. I want to prove that ABCD in each of them is cyclic quad. Now stop the video, then solve the problem with the steps. Okay? Write the steps, then check your answer. Now the answer of number 2. And the answer of number 3. Now the last problem. In the opposite figure, line segment AB is a chord in circle M and line segment CD is perpendicular diameter on line segment AB and intersected at point E. Ray BM intersects the circle at X, and line segment XD intersects the line segment AB at point Y. Now, I want to prove that. First, XYEC is a cyclic quad. Where is XYCE? XYEC. This quadrilateral. Okay. Do you see the quadrilateral? XYEC. Now I want to prove the yellow quadrilateral is cyclic quad. How? I said before, I'm looking for about the property. Now, what is the given here in this figure, in this quadrilateral? As you can see here, I have measure of angle E. Measure of angle E is 90, this angle. If I have measure of angle X and this angle equals 90 also, therefore this quadrilateral is cyclic quad. How to prove that? Measure angle CXD equals 90. Let's see. Angle CXD is angle drawn in half circle, in semicircle. Why? Because CD is a diameter. Then measure angle X here equals 90. Therefore, this figure has two opposite angles supplementary. Therefore, the quadrilateral XYEC is cyclic quad. Let's see our steps in this required. Then I will continue explaining the second required. In circle M, since line segment CD is a diameter of the circle M, and angle CXD is angle drawn in semicircle, therefore measure angle CXD equals measure angle CEA equals 90. That means two opposite angles in the quadrilateral are supplementary. Therefore, measure angle CXD equals measure angle CEA equals 90. Therefore, XYEC is cyclic quad. The second required here, I want to prove that measure angle DYB equal measure angle DBX. Where are the two angles? Look at the two colors, the red angle and the blue angle. Okay, here the two angles. Let's see. Now I want to prove that the red angle DYB, this angle, equals in measure with angle XBD, the blue angle, this angle. Okay, XBD. What is the relation between the two angles, the red one and the blue one? Of course, there is no relation between them. So I will look for about other two angle or third angle with common relation between the two angles. So here I have angle. Look at angle C here, the yellow angle. This angle is inscribed angle XCD, inscribed angle subtended by arc XAD, and also angle XBD is inscribed angle also subtended by the same arc XAD. Therefore, angle C equals angle B. The yellow angle equals the blue angle. Now, what is the relation between angle C, the yellow angle, and the red angle, angle DYB? Yes, the angle BYD is exterior angle of the quadrilateral or cyclic quad CXYE. The red angle is exterior angle. Then the red angle, the measure of red angle equals the measure of yellow angle, measure angle C. Now, the yellow angle, angle C, equals the red angle, the exterior angle. And also, angle C equals angle XBD. Therefore, measure angle DYB equals measure angle XBD. The red one equals yellow equals the blue one. Let's see our steps. Since angle BYD is exterior angle of cyclic quad XY EC, therefore measure angle BYD equals measure angle C. This is number 1. Since measure angle C equals measure angle DBX subtended by the same arc XAD, this is number 2 from 1 and 2. Therefore, measure angle BYD equals measure angle DBX. Now, thank you for watching. See you later in a new lesson. Thank you and goodbye.